In this video, we will learn about one of type the Zener diode. When you think of a diode, you usually imagine an image like this. It has an anode and cathode, and there's a band on one side. The circuit symbol is represented as follows. Current input to a diode is output with a slight voltage drop. We call this forward voltage. Does this apply the same way to Zener diodes? Looking at the exterior, it looks similar to a standard diode. It has a band on one side and also possesses an anode and cathode. If you look at the circuit symbol, it looks similar to a standard diode. Standard diodes have a voltage limit. For example, let's assume there is a diode with a voltage limit of 5V. Let's place the diode in reverse bias instead of forward bias. If 5V is applied in reverse, the diode will be destroyed. More detailed information about diodes will be continued in the next video. The Zener diode uses this characteristic in reverse. This is a simple circuit for Zener diode. Can you notice the difference in how the diode is connected? In a standard connection, the anode connects to positive and the cathode to negative. However, for Zener diode, the cathode connects to positive and the anode connects to negative. How can the circuit be protected with the polarity reversed? Before looking at the circuit, let's understand the Zener breakdown voltage. Zener diodes have a characteristic where they discard excess voltage if it exceeds a certain level. This is called the Zener breakdown voltage, and the Zener diode activates when a voltage higher than this breakdown voltage is applied. We prepared a 5V power supply and a 5V Zener diode for a circuit. First, let's assume the simulation where 5V is applied. The Zener diode allows currents to pass normally without any changes. Also, 5V is output normally to the load side. At this point, the Zener diode is not yet active. Now, let's increase the input voltage to 6V. When power is applied, the Zener diode activates. Since the Zener diode's breakdown voltage is 5V, it removes 1V from the 6V and outputs only 5V. In this process, the Zener diode is not damaged. It is a great way to protect the circuit from unexpected voltage changes. When using a Zener diode, you shouldn't buy one just by looking at the Zener breakdown voltage. Like choosing any other electronic component, you need to clearly know the allowable current and resistance of the Zener diode. When looking at the datasheet, you might see terms like the following. Let's find out what each one means. This is the part related to voltage. First, this is the symbol for Zener voltage. It means the Zener breakdown voltage and is the most important piece of information. If we assume Zener voltage is 5V, it means that when the input voltage exceeds 5V, the output will be limited to 5V. Next are the current terms. We can classify them broadly into three types. First, continuous operating current. Second, maximum continuous current. Third, maximum surge current. It usually refers to the maximum current it can handle for less than a few seconds. Finally, terms related to heat and resistance. ZZT is the internal resistance. It is the internal resistance value when the Zener diode is operating. PD is the power dissipation. Like resistors, the allowable power is indicated, such as 1W. In this way, we have learned about the characteristics and terminology of Zener diodes. The next video will be about standard diodes, so please look forward to it. If the video was helpful, please subscribe and like buttons. Thank you for watching.